Good morning, students. Let us look into this question now. A body of mass 8 kg is suspended by a rope of length 2.5 meters from the ceiling. So let's say this be the ceiling, and through a rope whose length is 2.5 meters. There is a mass which is attached, which is 8 kgs. Now what are we doing? There is a force of 16 Newton applied on this body in the horizontal direction. So a force of F is equal to 16 Newton applied in the horizontal direction. Right. Find the angle that the rope will make with the vertical when in equilibrium. So as you can see, because of the applied force, the mass is going to be taking a new position and it is attaining equilibrium in this position. All right. So let's say this is the vertical. Let's say the mass makes an angle of theta with the vertical, which is what we need to find now. Since the mass is in equilibrium, let's analyze what are the forces which are there. One of the forces is the force which we have applied, which is F is equal to 16 Newton. And the other is going to be a force due to its own weight, right? Which is acting in the vertically down direction, which is m into g. Mass is 8 kg. G can be taken as 10 meter per second square. So that's going to be 18 Newton, right? Then the third force which comes into picture is the tension here, right? So let this be T. Now, because the body is in equilibrium, the net force acting on the body is going to be 0. Or in other words, I can say the force acting along the x direction is 0 and the net force acting on the y direction is 0. Before we go to that, let's resolve the vector here, for which I'm going to draw a line parallel to the vertical. Okay. Now tension, I'm going to resolve it into two components. So tension is going to be resolved into two components. Let me resolve it as one component along the vertical and the other component along the horizontal. So if you see, because this angle is theta, this angle is also going to be theta. Therefore, the component which is along the vertical becomes t cos theta, and the component along the horizontal is going to be t sin theta. Right? Since the net force along the horizontal is 0, there are two forces which are acting along the horizontal direction. One is F is equal to 16 Newton, and the other is t sin theta. Since the net force along the x direction is 0, I can equate the two. So I can say F is equal to t sin theta. Since the body is in equilibrium, even the vertical forces, the net vertical force acting on the body is also going to be 0. The net vertical force acting is 0, which means the downward force which is acting, which is the weight, is going to be balanced by t cos theta. So I can equate these two. So W equals t cos theta. Now, in order to find theta, we can divide these two equations. When I divide these two equations, I get F divided by W is equal to t sin theta by t cos theta. T cancels. Sin theta by cos theta becomes tan theta. Therefore, tan theta is equal to F by W. What is F? 16 Newton. W is 18 Newton. That is equal to tan theta. 16 divided by 5 is 1 upon 5. That is 0.2. So tan theta is equal to 0.2. Therefore, theta is equal to tan inverse of 0.2. So that is the angle that this rope makes with the vertical at equilibrium. I hope it is clearly understood, students.